In this tutorial, we are going to see how to deal with seasonality in forecasting using the annual method. If you've not done so, please view the introductory video first. Additionally, make sure that this approach to seasonality matches the one in your textbook. Keep in mind that there are several different approaches, so match your textbook. Using the data shown on the slide, we wish to prepare a forecast for next year using simple regression and adjusted for seasonality. Our first step is to prepare a chart of the data and check that seasonality actually exists. That chart is shown on the slide. As you can see, demand is increasing, so it will have a positive trend. You can also see a regular, repeating pattern of up and down movements, so seasonality is present. The next step is to arrange the data into a table, as is shown on the slide. Each row represents a full cycle. In this example, that is a year. Each column represents a single period. In this example, that is a quarter. Year 1, Year 2, Year 3, Quarter 1, Quarter 2, Quarter 3, Quarter 4. Step 3 is to get the row and column totals along with a grand total. For the rows, 91 plus 134 plus 200 plus 112 equals 537. 132 plus 189 plus 261 plus 147 equals 729. 139 plus 213 plus 288 plus 191 equals 831. These represent the annual demand values. For the columns, 91 plus 132 plus 139 equals 362. 134 plus 189 plus 213 equals 536. 200 plus 261 plus 288 equals 749. 112 plus 147 plus 191 equals 450. Finally, the grand total is just the sum of either the bottom row or the right column. You get the same answer either way. 362 plus 536 plus 749 plus 450 equals 2,097. Step 4 is to compute the seasonal indices. These are computed by dividing each column total by the grand total. 362 divided by 2,097 equals 0.173. And for all of the indices, I have rounded all of the results to 3 decimal points. 536 divided by 2,097 equals 0.256. 749 divided by 2,097 equals 0.357. 450 divided by 2,097 equals 0.215. What these numbers mean is that 17.3% of the annual demand happens in quarter 1, 25.6% of the annual demand happens in quarter 2, 35.7% of the annual demand happens in quarter 3, and 21.5% of the annual demand happens in quarter 4. As a quick check, these 4 numbers should add up to about 1. They would sum to exactly 1 had we not rounded the numbers to 3 decimal points. So any deviation from 1 is just due to rounding. In this case, 0.173 plus 0.256 plus 0.357 plus 0.215 equals 1.001, or about 1. Step 5 is to forecast period 4 using the 3 annual totals and simple regression. That gives us an intercept of 405. A slope of 147, and a correlation coefficient of 0.98474. Plugging a 4 into the resulting regression equation gives a forecast for period 4 of 993. Step 6 is to partition the annual demand into quarterly demand by multiplying the annual demand times the seasonal index for each period. For period 1, 0.173 times 993 equals 171.8. For period 2, 0.256 times 993 equals 254.2. For period 3, 0.357 times 993 equals 354.5. For period 4, 0.215 times 993 equals 213.5. The chart on the slide shows the actual values for periods 1 through 12 and the forecast for periods 13 through 16. The actuals are in blue and the forecasts are in orange. Notice how the forecast continues the trend of the actual and follows the same seasonal pattern. Using the next set of data shown on the slide, we wish to prepare a forecast for the next year using simple regression and adjusted for seasonality. Note that the intercept will be 845.7, the slope will be 104.5, and the correlation coefficient will be 0.98027. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. We begin by looking at a chart of the data. It clearly has seasonality along with a positive trend. We next arrange the data into a table and compute row totals, column totals, and a grand total. That is shown on the slide. Using the column total and the grand total, we next compute the quarterly indices as shown on the slide. Quarter 1 is 0.256, Quarter 2 is 0.243, Quarter 3 is 0.215, and Quarter 4 is 0.265. Next, using the simple regression parameters given at the start of the problem, we compute the forecast for period 4. That value is 1,263.67. Using the annual forecast of 1,263.67 and the indices computed earlier, we compute the quarterly forecasts. The forecast for Quarter 1 is 348.8. The forecast for Quarter 2 is 307.1. The forecast for Quarter 3 is 271.7. And the forecast for Quarter 4 is 334.9. The slide shows a chart of the actual combined with the forecast. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.